Welcome, everybody. Hello, I think we're all connected up here and ready to start our launch webinar introducing the SDR Play sponsored training materials for teaching the course Understanding Radio Communications using SDRs. And I see we've got about 20 or so people already on the webinar, and we hope to make this a very interesting and interactive session. So in a minute I'll go through the format, but I'm John Hudson. I'm based here in the UK and I'm one of the SDR Play team. I handle sales and marketing and technical support, and I'll pass it over to our two authors of this university program to introduce themselves. So first of all, Paolo.
Yeah, hello everyone, I'm Paolo Marzioli. I'm a PhD student at Sapienza University of Rome in Aerospace Engineering. I've been lucky to be one of the authors of this course. My major at Sapienza is nanosatellite or space systems development. Welcome to the webinar.
Okay, Lorenzo.
Hello everyone, I'm Lorenzo Frezza. I'm also a PhD student at Sapienza University of Rome. Like Paolo, I graduated in space engineering here at Sapienza, and I'm happy to introduce you to the course we developed.
Okay, well, it's certainly been a great pleasure working with you guys as you prepared the materials that we're sharing today. And I guess we're all very much in lockdown over here in various countries. I'm in the UK. We're into the third week of our full lockdown. How about you guys? How are you doing?
The situation in Italy is evolving. It depends on region to region. I'm in Rome right now, so we are experiencing a beautiful November. The temperatures are high, but the situation is not that, I must say, great. We are allowed to go out, but it's still, it feels a little bit like a small lockdown, let's call it like that.
Yeah.
Okay. Well, hopefully we can brighten the outlook by discussing this very exciting course. I would like to just say we've got about half an hour of presentation material, but we'll then throw it open to try and answer the questions that you may have. So you'll see if you go to the chat on the YouTube channel, we'll be looking at that live chat and we'll take your questions and try and do our best to answer them. If we run out of time, we've got plenty of time. We'll be running for an hour and a half if needed. We can, if we can't answer your questions here and now, we can follow up on the forum, which we'll be introducing, and we'll tell you where to look for answers later on. So let me talk a little bit about the background here. So this course came about after we'd discovered quite a few universities were using the SDR Play RSP1As to do basic teaching, and after talking a bit more about why that was the case, we thought it would be good to encourage and sponsor the University of Rome to put together a module, and they'll talk a bit more about that in a moment. But basically, the course that you're going to see here, it uses SDR Play hardware and software, and it uses GNU radio software really to inspire STEM students in an exciting and engaging practical way. I mean, you could actually create a similar course using lower cost dongles, but by using the RSP1A, you get immunity to interference, you get repeatability, and most importantly, those students end up being able to perform truly to explore the radio spectrum with the same level of performance you would get from a commercial communications receiver. So that's the background. Obviously, it's good for us, but I think it's very, very important to try and encourage newcomers to radio. So I'm going to just share my screen with you, and Okay, and is the screen on? Good. Okay, so so obviously as I say, we have an interest, but it's a lot more than that. Digital wireless communications are a fundamental part of modern electronic and computing systems. And if we go back 20 or 30 years, most undergraduates in electronics and telecommunications studied the basics of RF and fundamental modulation techniques, analog techniques, CW, AM, FM, and so on. But since then, this chapter of learning has reduced or disappeared, and for many, digital RF has become a black box. There's also a serious chasm between other STEM subjects which naturally link to modern RF communications. Computer science being one, where if only we could inspire some of those students to fall in love with what RF can do, they would be able to go on and become great innovators, working across disciplines. So this course provides an interesting and practical way for the students to learn about digital wireless communications and to put the techniques to work, receiving, in this case, telemetry from those hundreds of CubeSats that are in orbit around the Earth. It's a fun way to learn some wireless fundamentals and out of it have a useful toolkit. So, yeah. Oops. Lost control of my screen there in the process. Okay, sorry about that. Just go back to this. Okay, so when we say course, we talk about the course. What we mean, it's a complete, out of the box, ready to roll set of lecture notes and slides and handouts, lab setup guides, video guides, and a forum where you can interact with other teachers who are teaching the course or those who've taught it before. It started life as a 12-hour optional course, as Paolo and Lorenzo will describe, for third-year bachelor students in aerospace engineering, but has been broadened to make it suitable for all students that have some basic knowledge of signal theory and signal processing. So this course for STEM undergraduates it's ideal for nurturing a real appreciation of radio communications through hands-on practical learning, with step-by-step learning how to receive satellite signals. It gives reliable, repeatable, quality access to signals all the way from 1 gigahertz up to 2 gigahertz, and it's a springboard to exploring the rest of the spectrum. Just stop sharing the screen now. Okay. So anyway, working with Paolo and Lorenzo has been a real pleasure. We've had to do it through lockdown. It did mean I never got to get to Rome this autumn, which I was really looking forward to. But I think you'll find that what we have here is something which should become a kind of a honeypot, an inspirational hub from which many other teachers of STEM subjects can take these materials, build on what they see here, and tailor it for their own learning situations. So hopefully today we're launching that. We're going to show you everything involved and give you something to really help create more innovation around RF for the future generation. So without more ado, I'd like to hand over to Paolo to say a little bit more.
Yeah. Okay, I would share my screen. Should be on in a little while. Okay, basically I prepared a few slides to tell a bit of story behind the development of the course. What is our background? Why did we come here? Basically, I will start immediately from what we do with SDRs. We are aerospace engineers, me and Lorenzo, as we said, and what we basically do is to develop CubeSats, so nanosatellites, satellites that are below 10 kilograms of mass. We take care with our research group of the design, the development, the testing, and even the launch and operations of the CubeSats. So basically, SDR are often used during testing and during operations of satellites. What we also do is to develop, when we can, some stratospheric experiments. And we developed 2 of them in the last 4 years within the Rexus program. Especially here are some old pictures of us from 2016. My first hands-on experience as a master's student in aerospace engineering, in aeronautical engineering, actually. It was with this stratospheric experiment that you can see in the right-hand picture. You see our team member Andrea that is measuring the antenna pole. Basically, that black box that you see was launched in stratosphere along with other student experiments and was carrying one RSP, one SDR Play RSP on board to measure the VHF, to record the VHF spectrum, and to measure the possibility of applying the VOR navigation system to stratosphere. So we were using for our first time an SDR. Actually, we came in touch with the world of SDRs that year because we were told that it could be interesting to bring one of them into stratosphere, and we learned how to use it. And you can see me, Lorenzo, and our colleague Federico. That white surface is basically the balloon after it's brought back to the launch base, and you can see also the payload in this picture. We continued a bit our investigations and also our projects up to arriving at last year, 2019, when some of the students from our lab developed this TARDIS experiment, which was another project, and actually SDR Play was supporting the project, providing us with RSPs, and 2 of them, I think, or many of them, I think it was 2, they were brought on board the box that you can see in the picture. You can see the students at work. So this is how we basically came in touch with this world. We didn't know anything before 2016 about SDRs, and we arrived to an idea when we were first contacted by John to probably try to give a course for introducing all the students to the SDR world, because for us the learning curve was extremely steep, and we didn't know anything like in January, and in March we started our experiments on VOR. And for us, it was important to give some practical examples. And for aerospace engineers, you can imagine that providing an example on satellite communication, how to receive a satellite, is extremely catchy for students. And it's a good challenge that can foster the interest of students into playing with this technology. As I said, we were trying to help the learning curve by fostering some interest into SDRs. And providing some do-it-yourself example like satellites, because of course you can do it during the course, and the best result we could get, it was if after the course, for example, some of the students could be interested at the point that they started receiving satellites on their own. This was extended a little bit when we decided to expand the course in collaboration with SDR Play, and basically to turn our internal course for aerospace engineers into a ready-to-use set of materials. You can see this kind of diagram. It's like a ready-to-use box, and the main elements we discussed on and then we developed, and they are the main elements that are now composing the teaching materials are slides, of course, because you will need to project when you give the course some PowerPoints describing all the experiences, and the aim was to provide as many lab experiences, as many practical exercises as possible. Then to have some setup guides to tell the teacher basically what is needed before the course start, what's the background of the students, and etc. And there are guides in the teaching materials that you can download that are explaining what should be the background of the students, what should they know. This is not substituting, for example, a classical signal theory course, so they should know something, and there are some recaps and etc. And then we are still setting up some videos. We will see an example in a little while to guide you through the most important practical experiences, because maybe students want to rewatch the experience after the course, or maybe the teacher wants to see what are you actually doing on the computer. And then we have a forum that is open for your questions, your doubts, and also to share your experience or our experience on how to give the course, or maybe how to perform the exercises during the class. With that, I will stop sharing my screen, and I will hand over, I guess, that will go in more detail about the contents and the topics of the course.
Thank you, Paolo. Okay, I'll share my screen. This one. Okay. So you can see here the brochure of the course. In the package, we provide a list of the hardware which is necessary to learn the course. Mainly an RSP from SDR Play, an Arduino, an inexpensive transmitter, which we use to transmit signals to the students. And you would also need an antenna and an amplifier in order to receive satellite signals, which we do at the end of the course. We also provide the software, which is required for the course, which includes SDR Uno from SDR Play to use the RSPs, and also GNU Radio, which is a popular software which is used extensively throughout the course to analyze the signals. The course is then divided into 11 lectures, which include both theory and lab examples, where the students can actually pick up an RSP and play with the signals. The course starts by giving an overview of SDRs, how they work, the main parameters, and what are their signals and how to interpret them, giving a general overview. Afterwards, we move to an introduction of the GNU Radio software, which is a tool often used with SDRs to help with receiving, demodulating, and interpreting signals. And we give here an introduction, and we try to make the students receive actual signals. In this case, we try to make the students receive and demodulate FM radio using GNU Radio and an RSP. By actually building the blocks necessary to do everything. After we gave a setup on GNU Radio and SDRs, we talk about how data is transmitted, keeping in mind the reception of satellites. And we have 2 lectures dedicated to an exercise where the students try to receive data from the Arduino transmitter, which behaves similarly to a transmission from a nanosatellite. And so there the teacher transmits the signal with this transmitter, and the students with the RSPs and GNU Radio try to receive them and to interpret the data. The course concludes then with the last 3 lectures, where it's a more in-depth description of the reception of satellite signals, with a final exercise where the students can actually try to receive a nanosatellite from orbit using an RSP, radiometer tools, and an antenna. We're also producing, as Paolo mentioned, a series of videos, 5 videos, which will be ready by December. You will find them on the educational channel of SDR Play. And we actually have already the first video. It's an introduction to the course and to the first exercise, where we give a setup of a simple example of radio reception using an RSP. I think now we can switch maybe to give an overview of the video.
Hello everyone, I'm Paolo Marzioli.
And I'm Lorenzo Frezza.
And welcome to the first video tutorial for the SDR Play course in Understanding Radio Communications using SDRs. The first lecture, named Hello World, is an introduction to the SDR world and to the first practical experience. With the theoretical slides of lecture 1, you already had a recap on what is an SDR, what can you do with an SDR, and what are the typologies of an SDR. Now the practical part is aimed at letting the students connect the RSP, probably for the first time, to a computer, and to see and receive actual signals for the very first time to check that everything works. Okay, let's get started. You don't need anything more than SDR receivers. We have a couple of RSP1As here. SMA antennas, we have a monopole here, and USB Type B cables for connection to your computer. The connection is simply performed by screwing in the antenna to the SMA termination of the SDR and then plugging the USB Type B cable. And then when you're ready, you can plug in the USB termination into your personal computer and start up SDR Uno. Okay, Lorenzo will show you now how to start up SDR Uno and how to receive your first signals.
Hello everyone, let's go through with an introduction to SDR Uno, the main software for operating an RSP. The software is released and maintained by SDR. Okay, and then the video continues with the setup of the example and the reception of some signals. You will see the rest of the videos which will come out on the channel. And I will also mention that we have a support channel in the form of a forum, which John already introduced. You can find the link in the brochure. And I think also in the description. There you can ask questions about the materials, how to obtain them, and generally, if you have any problems with the package, we are there to help and answer any question. I think for me it's done. Of course.
Okay, all three again. Okay, so that's really good. That gives, I think, a nice clear picture of what's gone into the course and what the materials are. So I think we're now ready to take some questions. I see here's quite a technical question. I think I guess this was more in relation to the SDR that went into the Strasbourg. I don't know. The question from Erasmo Benedetti is: was a bakeout ever performed on the SDR? Is a system bakeout possible?
Yeah, it's launch. I think it's an aerospace engineering. It's as it called, an environmental testing that is needed for launching stuff into stratosphere. Of course, you need. I don't think you will need it for a stratospheric experiment. We didn't perform bakeouts for satellites, of course, but we are not planning to launch any RSPs in the moment on satellites. I don't know, Lorenzo, okay. You want to complete the answer, but yeah, nice question, by the way. It's it's okay.
Okay, so yeah, that was very much in relation to how this all started, but obviously for teaching purposes, this is very much a earthbound application. So I've had a question here from Kanji969 saying, hi, SDR Uno works, does it only work for the RSP, or does it work for other SDRs like the RTL SDR dongles? So, I mean, I could probably take that myself there. And just to say that the up-to-date versions of SDR Uno are very much tailored for the RSP family of SDRs. There is a legacy copy which will work with the RTL SDR dongles, and that's available every time you download the latest SDR Uno. There's an XTIO version which will support anything that has an EXTIO interface to it. So it is possible to use an earlier copy of SDR Uno for other dongles. Okay. Yes, I believe, Christian, I'm so sorry, because I think we swapped, I did see your name pop up, and I understand that you were having problems. I thought we'd fix that, but I will pick that up afterwards personally, Christian, and just see what happened. Do check your spam folder, by the way, because sometimes our ticket system responds in a way which certain servers treat it as spam. So just check your spam folder. The process we have, if you for downloading materials, is fairly streamlined, and you should be given a password, a clickable link, which will give you access to the download, and a password, which is sort of assigned to you to be able to download the material. Sometimes, as I say, things can go wrong, and I think some, particularly, it is a bit of a problem with some universities, depending on the breadth of the university and some of the activities going on there. They can sometimes fall foul of the various anti-spam systems. So, but we'll work with you and find a way around whatever your problems on that. We're obviously very keen to get these materials out. So here's another question. Oh, okay. I'll reset and get back to you, Christian. Thanks for that. Yeah. So another question. This is from Warren Ziegler. Hi, Warren. Do the students need to understand FFTs as a prerequisite? Paolo, do you want to take that one?
Yeah. I mean, we have a recap throughout these slides about classical signal theory. So it includes FFT, or at least the Fourier transform. It doesn't go into very much of a detailed description of how FFT is calculated, or even how is Fourier transform representation of signals in the frequency domain. So what we advise, and it's written, I think, in the setup guide for the teacher, is that the students should have at least a minimum base of communications, so signal theory, including Fourier transform. And then we use it. We take it from a very practical way. So you use that tool. If you don't remind immediately what it is, I will present in a slide what it can be. But I wanting to get into a very high, let's say low, so very low level of detail on what is a Fourier transform, or how FFT is calculated. So my answer is I would say yes, they have to have a background, but you will find some recaps that can be useful for many of them. Lore, do you have something else to add?
Nothing to add. That is all basically. We try to give another introduction to the FFT and the transform itself, but having a knowledge base is very helpful during the course.
Okay, thanks for that. And also hi to Cornelius who comments he'd be very interested to include a satellite comms chapter in his comms system course, but unfortunately he's only got 28 hours for the course and 14 hours for lab, so it would take obviously a sizable chunk of that. So I think that's part of the challenge, but it may be possible to home in on a subset of this. And of course, we do encourage people to mix and match and do whatever you can to blend together anything that's useful from here. So that's I suspect that's a common issue, particularly if you're trying to sort of integrate it in the short term and can't have any say over the timetable. Another question is from Kanji again, Kanji 969. Does SDR Uno work on Mac OS and Linux? So SDR Uno at the moment is Windows only. So it's Windows. It'll work on a variety of everything back to, I think it still works on XP, but through Windows 7, 10, and so on. You can run it under Parallels under a virtual machine on the Mac, but it doesn't run natively on the Mac or Linux at the moment. Now, we have on our roadmap for version 2.0, and work is well progressed on this. We do have work underway to have it migrated to both Mac and Linux, but it's very, very hard to put a time scale on it. So certainly in terms of this academic year, you wouldn't want to plan around having it on those platforms, unfortunately. So that's just a fact of life. It might be interesting to understand. I mean, you guys obviously chose Windows as a platform. Maybe you could talk a little bit about why you chose to use a Windows platform for this teaching. Maybe Paolo?
Oh yeah, it's simple. We started thinking about our students, and usually you find out that a great percentage of students have a Windows, a computer running on Windows. So at least at a university, I must say it should involve more students that have that kind of platform ready to use more than Mac and Linux. Lorenzo, I think you agree, right?
Yeah,
you find.
Yeah, in our university, most of the students have a Windows PC. It might be not the case, maybe in other countries, but it is, at least here, that's what we found.
Yeah, I think that's interesting. And obviously, one of the things we want here is for people to carry on after the course, experimenting, maybe at home and wherever they live, actually starting to get excited about building antennas and sticking up special antennas and wires to see and pulling signals across the spectrum out of the air. So for that, again, access to a prolific platform, I guess Windows kind of wins. I know there's it's almost like a religion, the way people feel about these different platforms. And we do recognize that there's a tremendous amount of innovation that goes on Mac and Linux, and so hence why SDR Uno will migrate over time. So that's an interesting one. So Cornelius comes back. Just says this. Cornelius, if you remember, was the one who's struggling to fit these materials into his course. He's saying so a selection or a compression could be necessary. Certainly, in terms of the slides, the slides are available to download for free, and you are free to edit them. We deliberately asked for them to be available not just as PDFs, but they're also there in PowerPoint, so you can tailor them to your own style. You can cut and paste and incorporate them with other materials. In terms of the other costs, obviously, I think just to recap on what we heard there, obviously you need access to Windows PCs. For each student, or in some countries maybe a pair of students, you could have two together sharing one RSP-1A, which would be of the order of 110, I think we say $110 price. That's and then if we add up all the other bits and pieces to set up a lab, to set up the dummy satellite transmission signals, that's going to round out at probably another $50-60. So I think for $200, you've got basically the infrastructure in the classroom, and also one RSP-1A that could be shared maybe with two students, and then you can just multiply up from that. In terms of getting educational discount, SDR Play does have a discount program where if you're buying in volumes, we can provide some discount. Other channel partners and resellers may be able to offer things. We're talking to RS Components at the moment, who carry the RSP-1A, about potentially having all the kit, the items available as a virtual kit, maybe even eventually more of a real kit. But at the moment, you can buy the individual pieces from places like RS, and you may have your own arrangements with people like them. So I think over time, if more and more people use the course, then hopefully that helps to ease the cost of the materials. So I have another question. Oh, sorry. Yes. Okay, so let me just catch up with the questions here. Actually, I've got here the next question. So just to close on Cornelius, yes, you can translate the documents for the course. We are looking at potentially having it translated into Italian and potentially Japanese. We have someone already looking at the French version, certainly, I mean, you are free to adapt to, for example, use other alternatives to the Arduino. I think this is really just a kind of, here's a good way that you can do it. Here's what these guys did, and this is how it works. So it's really, I don't know if you want to comment on why you chose the Arduino. That would be interesting, guys. Why an Arduino, for example?
Lore, I think it's all yours.
Yeah. The Arduino is necessary only to interface with the transmitter that we use, which is a transmitter from Texas Instruments called the CC1101, which talks in SPI, which is an interface that you can find in Arduino. So anything you have that can communicate with SPI would probably work as well. One drawback is that we provide the software already done with Arduino, so you can just compile it and run it directly, and you'll be ready. If you use any other platform which is not compatible with the Arduino code, then you would need to convert some of the code to make it work with that. But mainly it's just to talk with this chip from Texas Instruments.
Okay, thanks. So Michael is asking, is this course open for interested non-academics to follow along and participate? I guess the point here, Michael, is this course really is not one course. Today it's one course in the University of Rome there. From this point on, we hope this will become a course or will be part of a course in many, many different places. And then each of those people running those courses, who they make it available to, would obviously be up to them. But it's an interesting point. I know increasingly universities, particularly with doing more remote teaching, are trying to do outreach and open up and share some of their teaching outside the formal academic sphere. It's so that's a kind of general term. But just to clarify, what we're talking about here is a kit of materials for university teachers, for lecturers, to take this and then add it to their curriculum, either as a formal module, as part of a accredited part of a bachelor's course, or it could be a kind of a special interest extra course to run alongside the formal course, which of course is how it started at Sapienza. So another question, Warren, again, do they need to know Arduino and Python and C++? Do your students need to know all that stuff, Lorenzo?
Yeah, the course is structured so that you do not need to know any of these languages nor any else. So we program using GNU Radio, which is very intuitive, and it works with blocks instead of actual code. But we do have some extra content, especially when receiving the data from the transmitter, where if the students do know Python, then you can add to the content of the course and do some small programming to if the students are capable of. But it is not needed for the course. It's just for this extra part.
Okay. Thank you. And now here's a question from J.K. Zick from Germany. Hi there. Who's been using SDRs actively for some time. And he's wondering, would the course go deeper into communication network details? For example, like DRM decoding for broadcast signals on shortwave, or DMR, digital mobile radio, for VHF, UHF in communications networks. So I guess that would presumably be an additional course sometime in the future, right? I don't know. Are you looking at other courses yet, or are you trying to get this one going first? Paolo?
Paolo?
Well, yeah. I'm thinking about it. No, it will be interesting to add it. At the moment, it's the course is structured like an introduction to the SDR technology, and we just go a little bit more in detail with I guess the CSP, isn't it, Lorenzo? Help me out.
Yeah,
You describe.
Yeah.
Sorry.
No problem. Go ahead.
I was going to say, what I would see is that what this is all about is people who would never normally be trying to look at or do anything with radio signals suddenly are going to get excited about radio. Once they're excited, and then they start exploring, and it's kind of a crossover probably to the overlap world of even the hobby enthusiasts, radio amateur world, where suddenly they're gonna start to probably join some of those forums as well, and that's where all the experts are on these other types of communication. It's almost like there's a forum thing once you dig into it. This program and this forum and this focus is very much on that transitioning people who would otherwise, in their own little silo, in their own technical world, be brilliant at, say, computer science or other STEM fields, but to them, what is radio is just a weird thing that you just never spend time thinking about. This is a way to force people to invite people to spend 11 hours, and after that 11 hours, they will have seen some real, they'll have an understanding of, oh right, okay, so there's propagation, there's signals, there's decoding, and there's frequency, and it's just a very, very nice starting point for bright people who are doing science at university level to stumble into radio. And I'd like to just go back. I can't underestimate the power of the RTL SDR dongles. They are absolutely, SDR Play wouldn't exist if it wasn't for those dongles that have just got people going. Now that's fine if you're kind of a kid in your bedroom, or you got plenty of time, or a very focused single thing you want to do, and the dongle works great. But it's really, if you're trying to teach a class and you've only got so much time, and you haven't got time to do a kind of EMC survey on the room that you're going to do it in, what we've got here is something that should, out of the box, just kind of work in pretty much any classroom, whether you're next door to a hospital with a pager transmitter, a 500 kilowatt AM transmitter, where it removes a lot of the uncertainty and gives you the chance to have something that works, something that inspires, and then some of those people will go on afterwards to do more and more with radio. And I've often found the people who really innovate in companies or on their own are often very impatient people. They have this kind of sense of urgency. They've got the attention span of a goldfish, we say, but they're brilliantly enthusiastic. And, the nice thing about this class is it will set up. They won't suddenly get distracted saying, well, look, why is this signal here? I can hear this FM signal. It's not even in the FM band. And suddenly you've lost your audience as you try to shut this noisy, inquisitive person up. By having a class with around the RSPs, that should all flow well. So that and then they've got a platform to go off and explore the rest of the spectrum on their own, and that's where all this DMR stuff comes in, and whatever they want to get interested in next. So a very interesting question, JK. Thanks for that. And just to, you also ask about Tetra systems and WeatherSat stuff. I think the once you join the forum, or you look across to the other links to the SDR Play Facebook group and other groups.io forum, you'll find a lot of people there with a lot of interest in that kind of thing. So here's I think Robert Owen has just back around. Robert has been very much part of our program, helping us to guiding this whole activity and getting good quality teaching materials together. It's something he's done for many years for Texas Instruments, for Imagination Technologies and others. And he's commented on the chat here about yes, you can edit and mix existing materials. And he also emphasizes something I didn't mention: the materials are free for educational use. We don't want you kind of taking them and then selling them, but for education purposes, non-profit, if you have smart school-aged science clubs and you can adapt the materials, you're very welcome to take them and adapt them and use them, and just use the ideas here. Yeah, I've got one more question here. Perhaps you could say a bit more, just to sort of bring to life what you've been through to get to this stage where we've got such an amazing course available. What sort of challenges did you have with the lab setup? Actually getting it to the point where I think you said you had 19 students initially going through the pilot. So what sort of things did you come across? Challenges that you had to think about?
I guess the main problem setting up everything was having all the students have everything working at the same time, whether when playing around with the transmitters and receiving the radio, especially the first setup of the software, sort of distributing everything and having them download them and connect the SDR Play, the RSP properly. I would say that one was the most difficult part of the setup. From the teacher side, you only have to connect the transmitter if you're using it with the Arduino and press a button to start it. So there isn't too much trouble, let's say, in the setup itself.
Yeah. On my side, I mean, I wasn't into the pilot course with Lorenzo last year, but when we expanded the course, the main challenge for me, at least, it was to try to put my hat of aerospace engineer off and try to generalize as much as possible the concepts, because and also to find out something that can be exciting for every, let's say, engineer or even student, like STEM student in every field. For example, when we had to describe what is a nanosatellite, what is a ground station, we have those concepts, but making them clear and short enough to keep the interest of students, it wasn't that easy, because we live in our niche, so we have that kind of world, and putting ourselves out of that world is not always easy, but it was fun.
So in terms of the real life CubeSats, once you've completed this course, and obviously in the final class, you've really equipped everyone to actually, if they're close to a window pointing in the right direction, they can start to point an antenna and start to pick up the real signals. How easy is it after the class, when they go away and maybe try to work on their own to pick up real signals? Are these satellites always there all the time, or is it only on a Thursday night, if for 10 minutes? For those who are not familiar with how often these signals are, and are they in all directions of the sky, or is it just on the horizon? Give us a bit of a feel for that.
Okay, they are not still in the sky. They're not like geostationary satellites for broadcasting, so they are having passes. So Lorenzo will show in the video that you have to calculate the pass time. The software needs to know where you are and where the satellite is, and then you have a couple of minutes, I would say 10 minutes for pass. in those 10 minutes, you should be able to point in the right direction of the sky, or if you're using a monopole, usually it's easy to get the signal without pointing the antenna. And then you have your chance for those 10 minutes to get the signal from the satellite. They are not everywhere in the sky. There have been 1,000 as of now CubeSats that have been launched, and many of them are not operational anymore. But I mean, I would say it's frequent enough from most of the locations you can be in on the Earth. And you need to choose the right moment, and especially, I mean, if you're setting up the satellite lab in your class, you need to be careful and verify that maybe the satellite that you're searching for is not passing at 3 a.m. in the night, because it's possible. When you operate satellites, it's something that it's doable. I mean, Lorenzo knows it very well. Had a couple of encounters at late night with the satellites we were communicating with. You want to go on with the answer, I guess?
Yeah, I think you covered it all. There are a lot of radio amateur satellites that you can try to receive. Not all of them are, it's not always the case that you have one above you, but in general, within 15 minutes, you get one over your head. And if you're waiting for one specific, then yeah, you might have to wait.
And I believe you cover with some software how you can sort of download and get all the times and angles and all the rest.
Yeah. And also we give a general introduction how to receive most radio amateur satellites and CubeSats. So even if the teacher will try to receive a particular CubeSat that he knows is going to pass on that day of the class, the students can still have the tools necessary to go home and continue and receive whatever satellite they want. So we give as a general as possible view.
Yeah, thank you.
Yeah,
just going. Sorry.
Yeah. Just to say, and those tools usually are updated with high frequency. So if, for example, a student can come up with his memories like 3 months after the course, you don't have like the particular passes for those days. So you get tools that can be updated. So you just download from internet what's above your head on that day, and that's also important because with the materials, the aim was to give the students the possibility to redo those experiences at the time that they want and the location that they want.
Thank you. Okay, I'll just go back because So Young Han has asked the question, do we have to have a license prior to using the materials to teach a class? And so basically, when you download the materials, you have to accept the license, which is basically to acknowledge the fact that these materials are just for educational use and not for commercial purposes. So you effectively have that license once you have the materials. So it's a very simple license that you just click on when requesting the materials. So we've had a comment from Louis Miranda Kennert. Greetings from the National University of Asuncion. Working with GNU radio, is there some advantages between Windows and Linux? So could you comment on whether, obviously we're with Windows use of GNU radio, are there pros and cons, advantages, disadvantages for someone who perhaps has used GNU radio with Linux? What's the difference basically?
Yeah, there is a difference. Sometimes it is easier if you want to go more in depth on the radio and try to do stuff which is a little bit harder. Then Linux provides a good platform to build on and explore more options. The Windows version, maybe it's a bit more difficult to add onto GNU Radio more different things. But the introduction we provide works as well as Windows as it would on Linux. It's the part relative to GNU Radio and not SDR Uno, for example. But it would work, I think, also with Linux.
Okay. So I think just check the questions here if there's no further questions. I do appreciate everybody who's taken the time to join us today. I appreciate that this isn't necessarily a good time of day for many people, but to just again thank Lorenzo and Paolo for all their hard work on this. And in some ways, it's only just begun, because I think what hopefully we've conveyed here is that there's a great sense of fun, enthusiasm, and really we're planting a seed here, which we hope people will take and grow from. And it will really grow as much as it is useful. So if people start to find it useful and then you feed back in, I think the forum, which at the moment is just brand new, is just going to be the place where if you want to take time, download the materials if you haven't already, take a look through them, and then if you have questions, come to the forum, and that way you can hopefully get a good feel of how useful they may be to you. So the everything's accessible from the sdrplay.com website. It's sdrplay.com/understanding radio, all one word. And from there you have the links to download. You can download a brochure, you can print that out, maybe share it with colleagues. You can register to download the materials, and that takes up to 2 or 3 days. Typically it's within hours that you'll get a response to approve your download. And then when it comes to SDR Play or the Texas Instruments, the Arduino board and all the hardware, over time we'll try to make that more obvious and easy where you can source the materials. So that will come along as well. I'll just check to see if we have any final questions on the chat. Yes. Actually, Warren's asking, when does the course start? So basically the course, just to emphasize, is the each university will create its own course and have its own start and stop date. So follow the forum, and I think people will be sharing as they start to teach this, where that's all happening. So another question from Kanji, when are you going to release the lecture videos? I think, do you want to just take that again, Lorenzo? When are the lecture the videos coming out exactly?
Probably Paolo has a better answer than me.
Yeah, I'm editing the videos right now. We published the first video lecture for the introduction, so you know how to connect everything. I am working on the other lectures. It will be the 2 lectures about the GNU radio introduction, and then the 2 lectures about the transmission of dummy signals from the telemetry signals from the dummy transmitter. I'm sorry. I think within a few weeks. So before December we should be ready. And you will see them on the channel. You can subscribe and be notified when we publish the other videos. Now they are in their editing stage. I'm not let's say the best director ever, but I'm doing my best to do it as quick as possible.
Okay, that's good. Meteo091 says, hi, what's the best Linux distro for GNU radio?
I don't know if I'm the one to answer.
I guess since you guys aren't using the Linux version,
yeah,
may not be
I
able
used
to.
it, but I really found no difference between the different distros for GNU radio. There are some made specifically to run SDRs, but I wouldn't know which one is the best.
There is quite an active Facebook group with a couple of thousand people on. If you go to Facebook groups and search for GNU radio, I think that would be probably a good place to get an answer to that one, Meteo91. And, Istvan, hi to you. Yes, thank you for the nice materials. And sounds like you're waiting for your hardware to arrive to start working on it. That's good. So
good.
Do use the forum. Any questions once you start working on it? So, well, I think we're just on the hour now, but thank you so much again, and thanks everyone for watching. And if we haven't covered anything, just come on in and come into the forum, ask your questions, and if needed, we can plan a kind of follow-up live webinar if that starts to make sense over time. But I'd like to just say from everyone at SDR Play, we've really enjoyed getting this far, getting this thing off the ground, and really just feeling that we're encouraging a new generation of innovators with radio in our small way. So thank you, everybody.
Yeah. Thank you so much. And from me and Lorenzo, we have been excited to contribute to this. It was a kind of first experience in developing a course for third parties, for other people that may join in the future. It was extremely exciting. If we are contributing to spread I was reading the comment, to spread the virus of interest into SDRs and communication, we are more than happy to be spreading this wave, let's call it like that.
Yes, thank you.
Okay, thanks everyone. Bye-bye.
Thank you, bye.
Bye everyone.